Hi everyone, thanks for looking in. I'm often out in the field shooting landscapes, and when I find myself on soft or sloped ground, the feet of my tripod need to bite into the earth to provide a stable platform for the camera. Since there is no provision for accommodating spiked feet on the tripod I use, I modified the ends of its tubular carbon fiber legs to accept a threaded spike. And although commercial spikes are available, I decided to make my own. Here's what I ended up with. A short aluminum plug with a female thread fits inside the end of the tripod leg, with an aluminum sleeve adding extra support for the thin-walled carbon fiber tube. The body of the spike is made from aluminum for light weight, with the tip being mild steel. The spike simply screws into the end of the tripod leg. When not in use, the spikes may be stored inside the tripod center column, and the original rubber feet slipped over the leg ends. Here's a length of 3/4 inch or 20 millimeter round aluminum bar stock chucked in a collet. The first order of business is to turn most of the spike length to a base diameter. The actual dimensions of the spike are not set in stone, and although I have a pretty good idea of what I want, the details of the design are basically being finalized as the part is being machined. Or to put it another way, I'm designing this thing by the seat of my pants. Ah, that's the number I was looking for. Yes, I'm still using that ancient system of measurement based on feet and inches. Next on the agenda is to put a knurl on the short upper section of the spike to provide for a secure grip. A scissors type knurler is being used. This clamps the rotating part on opposite sides, so most of the cutting pressure is borne by the two rotating knurls. Knurling softer metals, such as aluminum, brass, and mild steel, is not difficult, and a sharp, crisp knurl gives off the impression that the machinist who made it really knows his or her trade. The knurled section receives a small chamfer to give it a finished edge. Now it's time to put the taper onto the spike. This is done with the top slide or compound rest. The correct angle is pretty much determined by trial and error. The workpiece is sticking out a fair distance from the chuck, so I'm not going to be taking real aggressive cuts here. I want to extend the taper almost all the way to the knurl, leaving only a very short cylindrical section. This short section will allow a collet to grip the part when it is turned around for further machining. Those long chips are a real nuisance. I'm just using a high-speed steel cutter here, but one advantage of using a tungsten carbide insert cutter on aluminum is its ability to break the chips. Sometimes, anyway. The steel tip of the spike will simply screw onto the end of the spike body, So the spike is being drilled to be tapped for a 1/4 inch or 6mm screw. As a rough attempt to hollow out the spike to some extent, I'm actually drilling far deeper than is required for the screw threads. A countersink will provide a nice chamfered lead-in for the thread. I'm rotating the spindle by hand to feed in the tap and cut the thread, but really I could have power tapped this. After staring at the part for a minute, it was clear that I could reduce the diameter of the tapered section a bit further without affecting the structural integrity of the spike. Cutting off the spike is pretty straightforward. The parting blade is actually cut from an old carbide tip circular saw blade and sharpened on a diamond stone. I don't like trying to catch the separated workpiece in my hand as it breaks loose, so I leave just a tiny stud and wiggle it off. Turning the part around, I want to drill and tap it for a short threaded stud that will allow the spike to screw into the socket in the end of the tripod leg. A spotting drill allows the tap drill to start on center without wobbling. I'm going to drill into the spike until the new hole meets up with the hole that was drilled from the other end, thus hollowing out the spike in a crude way. I want the spikes to add negligible weight to the tripod. some go juice and the hole is ready to be tapped. The part is being held in the collet on only a very short section adjacent to the knurl. Tapping puts a lot of torque on the part, so I want to proceed carefully so that the spike doesn't start spinning in the collet. And I'll finish off the threads by hand with a tap wrench. So there's the finished spike body. I'm just using some 1/2 inch or 13 millimeter diameter mild steel bar stock for the spike tips. I'm not really concerned about them rusting. One could use tool steel and harden them, or stainless steel, but I had neither of those on hand. The spike tip will simply screw onto the end of the spike body with a short 1/4 inch or 6 millimeter threaded stud. Power tapping a blind hole is a little scary, so I'm just using a tap wrench by hand. Here I've turned the spike blank around and screwed it onto the end of a length of threaded rod held in a collet. The cone angle of the spike tip is not critical, and I just chose an angle that looked about right. A file is used to put a shallow point onto the tip. That tip is screwed on pretty tight, and a strap wrench is just the thing to get it off without leaving marks. Here are the finished spike body and spike tip. Since under some circumstances the spike could exert some leverage on the end of the thin-walled tripod leg, a thin aluminum sleeve for the outside of the carbon fiber leg will provide extra support and preclude the leg from splitting or cracking. The sleeve is being machined from solid bar stock, first drilled out and then finished to size with a boring bar. A telescoping or snap gauge is a convenient way of measuring inside diameters. Parting off the finished sleeve is a piece of cake. The last piece to be made is the threaded socket that will fit into the end of the tripod leg and receive the spike. I'll make it an interference fit with the inside diameter of the tripod leg, which will preclude any wobble of the spike when attached. After the correct diameter is obtained, it's pretty much just drill and tap for the 3/8 inch or 10 millimeter screw thread, and then parting the socket to length. Now it's time to assemble everything. You can see how thin the wall is on the carbon fiber tube that forms the leg section. The outer sleeve is simply tapped into place with a plastic mallet. The threaded socket is also tapped into place. Before installation, I dabbed some silicone RTV around the socket and inside the tripod leg. The spike now neatly screws into the end of the tripod leg. I also machined a small groove into the base of the spike screw, and an O-ring seals the spike where it meets the socket face, and also adds some additional friction that's helpful in keeping the spike from unintentionally coming unscrewed. When the spikes are not needed, the old rubber feet can still slip over the end of the leg. Later, I thought it wise to pin the leg end parts together using a small set screw, thus preventing any possible tendency for the socket to rotate. The set screw threads right into the body of the socket. So now the tripod has gained some extra stability for working on rough ground. And, as a bonus, a leg with a spike on the end acts as a handy walking stick when maneuvering down the proverbial slippery slope. Well, that's it for now, and thanks for watching.